Hello students, in this video we will solve some more numericals on beam reactions. So let us start with this cantilever beam first. Right, the type of this beam is cantilever, that is fixed at one end and free at the other end. And three loads are working: 5 kilonewton, 5 kilonewton, 2-point loads, and one UDL, uniformly distributed load of 10 kilonewton per meter. Right. So let us name these points. This is point A and point B. How many reactions will we be getting here? One vertical reaction, right? One horizontal reaction and one moment, right? These three reactions you will get here. So let us name these as VA, HA, and MA. This is vertical at A, horizontal at A, and moment at A. Now, first condition will be sigma h is equal to 0, which means algebraic sum of all horizontal forces acting on this beam are 0 because the beam is in equilibrium. So that means that HA is equal to 0. Right? There is no other horizontal force, so HA is equal to 0. Next condition we will use is sigma V is equal to 0. Now, one vertical force, that is VA, it is going upwards. So let's equate it with all the downward forces. So VA is equal to, right, VA is equal to these forces, 5 plus 10 into 2 plus 5 is equal to, you get it as 10 and 20, 30 kilonewton. So one reaction you get vertical reaction at A, that is 30 kilonewton. Next, sigma m at A is equal to 0, right? So one anti-clockwise moment you get is this MA. Let's say this MA is equal to all these clockwise moments that will be coming from this external loads, right? So MA is on one side and on other side, let's equate all these moments. So let us first take this 5 kilonewton force. So moment of this 5 kilonewton force at point A will be 5 into 2. And what will be the direction? Let's take this force to A. This rotation is clockwise rotation. So it is plus 5 into 2. Next moment is due to this UDL. Now you can consider the location of this UDL at the center. So this UDL works at the center. Let's take this to point A. It is also clockwise rotation. So plus. So plus 10 into the distance, the length over which this 10 intensity UDL is applied, that is 2. And the third term here will be the distance of this UDL from point A. That will be half of this, that is 1 meter plus 2 meter. So third term here will be 3, right? Plus the last force, the moment will again be clockwise, 5 into 4. This will be MA, right? So MA will be this 10 plus 60 plus 20, that is 90 kilonewton into meter. The unit of moment is kilonewton into meter, right? So this is your first reaction, that is HA is equal to 0. Second reaction, that is VA is equal to 30 kilonewton. And third reaction is MA, that is 90 kilonewton into meter. So this is how you solve cantilever beams and find reactions for the same, right? Let's move on to the next example, example number 4. Now what is the change here? Here, this is a simply supported beam, but one force is 40 kilonewton that is working in inclined direction. So let's say this angle is 60 degree. Okay, angle is 60 degree. Now, how many reactions here? Two. One VA, second is HA, and third one is VB. Okay, considering A and B here. So again, first condition will be sigma h equal to 0. Now, before putting the conditions, equilibrium conditions here, we will dissolve this 40 kilonewton into two parts. One will be, right, one will be the vertical component of it and other is horizontal component of it. Okay, we will divide this force into two parts. Consider these two as shadows of this 40 kilonewton force. So this horizontal component will be 40 cos 60 degree and vertical component will be 40 sine 60 degree, right? This is simple. This is adjacent side, this is opposite side of the angle. So this is cos and this is sine. Now we will put the conditions. So first condition we know that is sigma h is equal to 0. Now how many horizontal forces do you see here? First is this HA. It is going in positive x direction, right? Positive x direction. So we will write it as plus. Second is this 40 cos 60. It is going in negative x direction, left hand side. So we will write it as minus 40 cos of 60 degree is equal to 0. And simplifying this, you get HA, right? HA will be, let us calculate that. HA will be 40 into cos 60, that is simply 20, right? Cos 60 is 1 by 2. So HA is 20 kilonewton. So this is your first reaction, HA. Second, you will do sigma V is equal to 0, right? Sigma V is equal to 0. Now, let's equate the vertical forces here. First force is this VA, second is VB. Both are going upward, so we will write them as positives. So, VA plus VB minus 50 minus 40 sine 60. Right, in vertical component, you will only consider this sine one. So 40 sine 60 is equal to 0. Okay. So simplifying this, you will get VA plus VB is equal to, let's take two forces on the other side. They will become positive for 50 plus sine of 40 sine of 60. You get 84.64. Okay. This is you get 84.64 kilonewton. Let's call this equation 1. Now move ahead to the final equation, that is sigma m at A is equal to 0. So we need to take moments of all the forces at point A. So firstly, this forces HA and VA. There is no moment of HA and VA at point A because moment is, again we call this moment is F into D. So distance of these forces from point A is 0. So if distance is 0, moment is 0. So no moments due to these forces. Let's move ahead to this 50 kilonewton force. Now this 50 kilonewton force, take this to point A, it is clockwise, so it will be positive, right? 50 into distance is 2. Moment is force into distance, 50 into 2. Next moment will be due to this. Now again, you can't take moment of this 40 kilonewton. You will be taking moments of two components of this 40 kilonewton, that is sine and cos. So first let us take the moment of 40 sine 60. Again, this is going downwards. Take it to point A. This will be clockwise moment. So positive force is 40 sine 60 degree, right? Force is 40 sine 60 degree into distance from point A is 5. 3 plus 2, 5. Right. Next force, let us consider this 40 cos 60. Now this 40 cos 60 force, this will be passing through point A. We know that line of action of this force extends beyond this arrow. So you can consider that infinite. So you can say this 40 cos 60 passes through point A. So distance of this force from point A is 0. Right, you can say distance is 5 from here because this is passing through point A. Again, if here we have vertical forces, so we took distance as horizontal. This is horizontal force, we need distance vertical, and vertical distance from A to this force is 0. So no moment for this force. move ahead to VB. Now VB is going upwards. Let us take it to point A. It will be anti-clockwise. If you take VB to point A, it will be anti-clockwise. So we will write minus here. Minus VB into distance from A is 2 plus 3 plus 2, that is 7, is equal to 0. Now let's solve this. Uh, so you will get 100 here plus 40 sine 60 into 5, that is 173.2, is equal to, let's take this the other side and call it 7 VB. So you get VB is equal to, therefore VB is equal to 273.2 divided by 7. We are getting this as 39.03 kilonewton. Okay. Now we will put this VB into this equation 1 and take it to the other side and subtract it from 84.64. So VA, right? VA is 84.64 minus this 39.03. I'm getting 45.61. 45.61 kilonewton. So when a force is inclined, you find reactions like this. That is 45.61 is your VA, HA is 20, and VB is 39.03. Now you can do one more simple calculation here that is not always required, but let's see that. So this is HA and this is VA. Sometimes they expect you to find the resultant of these two forces, right? That will be called RA. Now this RA can be found out simply using Pythagoras theorem. So RA is under root of HA square plus VA square, right? And calculating it, you will get 20 square plus 45.61 square and root. So 49.80. I'm getting this as 49.80 kilonewton, that is Ra. And then you can call this as Rb. This is Ra and Rb. Because there is no vertical component at B, so Vb is your Rb only. Okay, so let's move on to the next example. Okay, now what is the change here? Here you have a simply supported beam, but your rollers are inclined here. Roller support is not in its usual position. It is inclined at 30 degree from horizontal. So in this case, you will get the usual reactions here, HA and VA, but this RB will be inclined. RB will not be simply vertical. It will be inclined because the action will be perpendicular to the rollers. So if rollers are at 30 degree from horizontal, RB will be at 30 degree from vertical because these are perpendicular to each other. So if rollers are at 30 degree, so this angle will be 30. This will be 30 degree again. Okay, so now you need to take two components of this RB. Okay, one component is this vertical and next is this horizontal. Now this is adjacent side, right? This is adjacent side. So we will write this as RB cos of 30 degree. And this is opposite side to the angle. So this will be your RB sine of 30 degree. Okay. So this is your example now. Two reactions here, HA and VA, and two reactions here, RB sine 30 and RB cos 30, and two external point loads, that is 10 and 15. So we have seen three conditions. So first condition will be sigma H is equal to 0. So your HA is going in positive X. So let us write it as positive. And this RB sine 30, it is coming towards this negative x-axis left side, so we will write it as minus RB sine of 30 degree is equal to 0. Right. We will call this equation 1 and we'll move ahead. Second equation will be sigma V is equal to 0. Okay. Sigma V is equal to 0. Now, what are the vertical forces? This is VA going upwards, RB cos 30 going upwards. So let us write them as positive. VA plus RB cos 30 degree. Next two forces are these 10 and 15. They are coming downwards. So let's put them as negative is equal to 0. Okay. We can simplify it a bit. We can write VA plus RB, or no need to simplify here. We will calculate in next term. So write this as equation number 2. Okay. Next, let's calculate moment at point A. So sigma m at A is equal to 0. This means that all the moments at point A, clockwise and anti-clockwise, algebraic sum will be 0. Now to calculate moments at A, these two forces won't create any moment. This is 10 kilonewton, 10 into 2. That is clockwise, so positive 10 into 2. First moment is this 10 into 2. Okay. Next is this moment 15 into 4. Okay, this is also clockwise, so positive 15 into 4. Then we will have to take moments of these forces. Now you can't take moment of this RB because this is inclined and you can't have inclined distance of this from A. So we will consider two components separately. Now this RB sine 30, this is passing through point A. This is in the same line of action. So this will be passing through point A. So no moments due to this RB sine 30. You get moment due to this RB cos 30, and that is RB cos 30 is going upwards. It will be generating anti-clockwise moment. So minus, you get this as minus RB cos of 30 degree. This is your force. And how much is the distance from point A? That is 2 plus 2 plus 2. That is simply 6 is equal to 0. Now what you do is you solve this equation and find out RB. So I recommend you do the calculation simultaneously. So let us find out RB. So 20 plus 60. I'm getting RB as 15.40. Okay. Rounding off, I'm getting 15.40 kilonewton. This is my force RB. Right, now you put this RB in equation 1, you get HA, and you put RB in equation 2, you get VA. So let's do that. So putting RB is equal to 15.40 here, you should be getting HA is equal to, let's calculate, RB is 15.40 into sine of 30. So HA is 7.7 kilonewton. Okay, and putting RB here, you should be getting VA. So let's calculate VA, that is 15.40 cos 30. Okay. I'm getting it 11.66. VA is 11.66 kilonewton. So this is how we get all the reactions HA, VA and RB. Now again, like previous example, you can find RA, that is under root of HA square plus VA square, right? Let's find out RA is equal to, from simply Pythagoras theorem, HA square plus VA square is equal to I'm getting it as 13.97. 13.97 kilonewton. Don't forget to write units, right? So RA is 13.97, RB is 15.40. So if you have a roller support that is inclined, you need to make components of it and then calculate it with same three conditions: sigma h equal to 0, sigma v equal to 0, and sigma m at a equal to 0. Now let's see one more very short example here. Okay, now look at this example. This is a simple overhanging beam, right, with the loads, two point loads and one UDL. But what you see here, if you cut this beam halfway vertically here, right, if you cut this like this, you see mirror image on both the sides, right? Mirror image means you have same loads here and same distances here. So this beam is, you can call it, this beam is symmetrical beam. Okay, this is symmetrical beam. Let's call this support A and support B. This is RA and this is RB. Now you don't need to do sigma V and sigma M and everything. If you find a simply supported beam, you simply calculate total load. Okay, total load acting on the beam. So what is total load here? It is 20 kilonewton one point load plus other is UDL, that is 20 into 4, and next one is 20 kilonewton, right? So how much you get from here? You get it as 120 kilonewton. This is total load. So RA and RB both will be carrying this total load equally because beam is symmetrical. RA should be equal to RB. So you can say that RA is equal to RB is equal to half of this, that is 60 kilonewton. Okay, this is how you can solve the symmetrical beam, but be careful. You need to check everything. The forces should be equal, load should be equal, as well as the distances here should be equal. Then only you can call this a symmetrical beam and apply this shortcut. So this is it for beam reactions. Give your constructive feedback and practice at home at least 10 examples you need to calculate yourself to be thorough with this concept. We will be discussing other topic in the next video. So thank you for listening.